Hello friends, welcome to the Agriculture channel. I am Jitendra Kumar Nayak, and now today in this class we are going to study about some properties of the soil. Which properties? That is physical properties, which will comes under soil physics, as well as it will also related to the water management also. Okay, so here let's start the chapter. So here in the soil, so you know that soil is a three-phase system. Okay, that means what is the physical properties you will study here. Okay, some of the physical properties we will cover here. So first of thing is that soil. The question will be asked whether soil is a one phase, two phase, or three phase system. Three phase means whatever the materials are there. So you are having three types of materials are there. You will find some solid material, you will find some liquid, and some that is air, or that is you can say gas or vapor. Okay, so in this case, if we will see in a normal soil, if we will see, this is the soil, this is the normal soil, and in this soil it is three-phase system. Three-phase means one is solid, which will about 50% part of the water. If we will take it 100%, out of this 50% part is solid portion. If we see the liquid portion, that liquid means it is nothing but the water. Okay, water in liquid form, it will vary from 20 to 30%, as well as air, it will vary from 20 to 30%. So on an average, in a normal soil, you can see the solid portion constitute 50%, liquid means water constitute 25%, and air or vapor it constitute 25%. Okay, so out of this solid percent, that is 50%, if we will see out of this soil mineral, you can say the soil minerals, it constitute about 45%, whereas organic matter it may be constitute about up to 5%. So this is on an average, it is not the exact value, it is the on an average we can differentiate the different composition of the soil. So this is the composition of the soil. So composition of the soil, basically it is three-phase system: solid, liquid or water, and air. Solid contribute about 50% on an average. Liquid or water it will also contribute about 25%. Air contribute 25%. That means if we will see in a normal soil, the 50%, but this is the 50%. So this 50% portion is of a solid portion, or the clay minerals were there, or organic matter is there, solid portion, and whatever the rest portion is there, and you can see whatever the rest portion is there, these are the pore space. That means 50% is present, or 50% of the space is occupied with the soil particles or solid particles, whereas the rest 50% are remaining the pore space. And out of this pore space, some 25%, half of this pore space is filled with the water, half of the pore space filled with the air. This is the normal concept on an average. Okay, so here you can see. Okay, then next, coming to, if we will say soil is a relative relation between the soil constituents. Now coming to this topic, relation between the soil constituents. As you know that soil constituent means what? It is nothing but just very recently we have studied that 50% part of this soil, it will constitute about the solid material. Rest 50% is the pore space will be there. Out of this 50%, 25% for water, 25% for normal condition on an average, it is filled with air. So in this case, if we will see what is the total volume, so we are taking this soil. Okay, we are taking this soil sample. So in this case, what is the total volume? The total volume, it will include both air, water and solid, because this is the total volume. And in this soil samples are there, and water also there, and some air particles will be also present. Yes or no? So total volume means it will include all air portion, water portion and solid portion simultaneously. Whenever we are considering the total mass or total dry weight, this is based upon the dry weight, you can say. And if we will include water, then it will be the weight. Okay, so that if we will say the total, if we will say normal, what is the total mass, then the mass will include both air mass, weight of the water and or mass or weight of the solid. This we will say as the mass total. But if we will say dry soil weight, that means we are in excluding, then you are excluding which part? That is mass of water. So mass of water will be excluded by means of evaporation. That means whenever you are taking a fresh soil sample, so if you are taking a fresh soil sample, this fresh soil contain the empty will be, the mass total will be mass air, mass of water plus mass of soil. But if you will take the one dry soil weight, then it will include only mass of air plus mass of soil. But you know, mass of air is very negligible. This is tends to 0. That means one dry soil weight is equal to mass of the soil. Yes or no? So now if we'll say this is the 50%, this is the 50% part is solid occupied by the solid, where rest 50 part is occupied with the pore space, and out of this pore space 25% is air and 25% is water. This is the air volume, air weight, water volume, water weight, soil volume, soil weight or soil mass. Okay, so this is the relation. Okay, so now next coming to some of the physical properties, some terminologies. Okay, so first one is particle density. So this is the particle density. So this is the particle density. And what is the particle density? As you know that what do you mean by density? Basic formula, the basic formula of density is mass by volume. So definitely the particle density means which particle? This is nothing but the soil particle. Because what in the soil system, what you have soil, you have water and you have air. These three things, because it is a three-phase system. Okay, solid particle, so not soil, it is solid particle, then liquid particle, that is water particle basically, and air particle. So particle density means which particle? It is nothing but the soil particle. So this, the volume will be mass of soil by volume of soil. Okay, which mass? So particle density means as you are taking which particle? Soil particle. So you should take one dry soil weight. So particle density is equal to mass of one dry soil divided by volume of soil. Okay, so now coming to bulk density. PD means bulk density. And bulk density is of two types. One is dry bulk density, another is wet bulk density. But basically what in agriculture sector you are using the dry bulk density more frequently. Okay, so dry bulk density means you have already excluded, here you have already excluded which part? Now weight of water. Yes or no? So bulk density means, always remember, in case of particle density, the denominator will be only volume of the soil, because as we are taking into the consideration only soil particles. So mass of one dry soil divided by volume of the soil. But in case of bulk, so bulk means the total you have to count. Okay, so as it is a dry bulk density, so you should exclude the weight of the water. That means the formula will be mass of one dry soil divided by bulk means you have to total, you have to take total as a section. That means the volume, total volume, and mass of one dry soil means ms divided by total volume means bt, and bt means what? Volume of soil plus volume of water plus volume of air. This is the thing. Okay, then next coming to wet bulk density. Weight means you have to include, here you have to include weight of water, because you are taking the wet bulk density. So here the mass of total will be mass of soil plus mass of water plus mass of air, because mass of air is very negligible, tends to 0, divided by total volume means volume of soil plus volume of water plus volume of air. So negligible 0, that means mass of soil, open dry soil plus you can say mass of water divided by volume of soil plus volume of water plus volume of air. This is the total, this is the bulk density. And as you know that what is the unit? Basic important question is unit. Density means weight by volume. This is the formula. So weight means gram per volume means centimeter cube, or we can say megagram per meter cube. This is the unit. Gram per, or we can say gram per cc. Cc means centimeter cube. So gram per centimeter cube or megagram per meter cube. This is the thing. Next, coming to, let us erase these things. Okay, so next coming to the you can see here porosity. So porosity is nothing but porosity means volume of, obviously the volume of pore space divided by total volume. Yes or no? Means out of the total volume, this is the out of the total volume, how much of pore space is present? You have to find out these things. Okay, so volume of pore space is Bf divided by total volume is Bt. So now you can, if you are having the value of ball density and value of particle density, then you can calculate the porosity by the formula 1 minus 1 means this is the is a total means 1. So out of this one you can subtract the value of a ratio between Bd and Pd. Okay, so if you want to calculate in percentage, then just multiply it by into 100%. Okay, so this is the thing. So if you want to deduce the formula, how the porosity, the formula will be 1 minus Bd by Pd. So you can see here, as you know that porosity means we can say porosity means what? Volume of pore space divided by total volume. Yes or no? So volume of pore space means, you know, total volume is equal to volume of solid plus volume of water plus volume of air. So this is volume of you can say volume of solid plus this is nothing but the volume of pore space. Yes or no? Because as you know that inside the pore space, either the pore space is occupied with water or the pore space is occupied with the air. So volume of pore space is equal to volume of water plus volume of air. So here total volume is equal to volume of solid plus or soil plus volume of the pore space. That means if you have to calculate the volume of pore space, so it will be total volume minus volume of solid. So basically here the volume of pore space will be volume of total minus volume of, you can see here, volume of solid divided by total volume. So if you will this will be Vt by Vt, individually you will separate this, then Vs by Vt. So now it will be 1 minus Vs by Vt, and if I can write this as Vs by Vt into Ms by Ms means mass of solid into mass of solid, because it will give the value 1, so there will be no change in the value. Okay, so now 1 minus, you can see here Vs by Vt you can see Bs by Ms. I can write this Bs by Ms into Vs by Vt. Yes or no? Because this is the same thing, I am rearranging it. So now it will be 1 minus, so it will be like this, this is the thing, this is which thing, you know, mass of soil divided by volume of soil is equal to Pd. Yes or no? That means volume of soil divided by mass of soil, it will be 1 by Pd. So this will be 1 by Pd into, you know, mass of soil divided by total volume is equal to Bd, ball density, so the into Bd. So now the formula will be 1 minus Bd by Pd. So this is the porosity, and the range, if you want to calculate into percentage, then just multiply into 100. So this is the formula, it will be derived from the this Bf by Pt. Okay, this is the porosity formula. You have to remember this formula also, because in entrance examination this formula will be asked, or some values will be given for the ball density. Let us see, the ball density is this and particle density is this, then calculate the porosity percentage. Okay, so I hope you have understood this formula as well as the importance. So now let us erase these things. So now if we will see what is the normal ball density, so you can see here the ball density, in case of ball density, In case of bulk density, what is the denominator side? Denominator side is Bt. But in case of particle density, the numerator is constant. In case of particle density, the numerator is only volume of soil. That means which denominator is more? This denominator is more. This value is more, but this value is less. But it is constant. Mass of soil in both cases it is constant. That means, as you know, that if higher the denominator will be there, bulk density will decrease. The value will be decreased. So that means always bulk density is less than particle density. Always remember. Again, as you know that here it is nothing but mass of soil. This is nothing but mass of soil divided by volume of total, means volume of solid plus volume of pore space. Yes or no? And this is nothing but 50%. This is 50%. That means on an average, the particle density will be 2 times. Particle density will be 2 times the bulk density on an average, because 50% here also there. It is if it is 100% in the denominator side, it is only 50%, less than 50% also, because you are taking the volume of solid 50%. Okay. So it is on an average. On an average, we can see the particle density is equal to nearly 2 times of bulk density. Okay. So in normal soil, you can see in normal soil, what is the bulk density value? In normal soil, the bulk density it varies from 2.65. We can say 2.65 megagram per meter cube or gram per centimeter cube. On an average, sorry, this is particle density because it is the larger value. Okay. So if we will see bulk density, it is around just half of this particle density, that is 1.3 to 1.35 megagram per meter cube. Always particle density is normally 2 times, nearly 2 times. Okay. So if you will see the bulk density, as you know that we will see what are the factors affecting bulk density. As you see here, volume of total means volume of solid plus volume of pore space. So if I will increase the volume of pore space, that means the total volume will increase. That means the bulk density will again decrease. So what if I am adding some organic matter? Then what will happen? It will increase the volume of pore space. That means the volume total will increase. That means the bulk density will decrease. This is the thing. Okay. And as you know that more the pore space, more amount of water will be retained. Yes or no? More amount of water will be retained in the pore space. That means as we are increasing the organic matter, it will increase the water holding capacity of the soil. This is the thing. Okay. So and if we will see in case of a very good soil, if we will say for a good crop condition, for good growth of crop, what is the optimum? We can say the optimum bulk density, and this optimum bulk density will be for clay soil. If it is clay soil, it will be 1.2 gram per centimeter cube or megagram per meter cube. And if it is sandy soil, then it will be 1.4 gram per centimeter cube or megagram per meter cube. That means here you can say for a good crop condition, what will be the bulk density? Optimum bulk density for optimum crop growth. For clay soil it will be 1.2, and for sandy soil it will be 1.4. And here you can see for clay soil the bulk density is less as compared to the sandy soil. Yes or no? Bulk density of clay soil is less than bulk density of sandy soil. As the clay content, the total porosity is more in case of clay soil, hence the bulk density is less. But if we will see size of pore, again we will study. Okay, so let us study also these things. Okay, let us erase it. Let us erase the thing. As you know that pore space, if we will see the pore space are of two types. Basically it is of two types. One is micropore, another is macropore. So if the diameter of the pore space is less than 0.06 millimeter, it is called as micropore. If it is more than 0.06 millimeter, it is called as the macropore. This is the thing. So as you know that in case of sandy soil, more number of macropore is present but less number of micropore is present. But in case of clay soil, more number of micropore is present, less number of macropore is present. Okay. So in the next chapter we will see in the macropore, it cannot retain water. It cannot retain water. Means this macropore water go downward by means of gravity, because the larger size it cannot hold the water. But in case of micropore, due to the small size, it will retain water, as you know that by the force of adhesion and cohesion. First the capillary rise will be there, and this micropores is more important with respect to the increasing of water holding capacity. If you are having more number of macropore, but you cannot increase the water holding capacity, because the macropore water will, by means of force of gravity, it will go downward. It will be the unavailable form water. It is the unavailable form of water. We will see in the next chapter, coming chapter. Okay. So the total porosity in case of clay soil is more, and it contains more number of micropore as compared to the macropore. But whereas the total porosity is less in case of sandy soil, but more number of macropore is present, but less number of micropore is present. Hence, if we see average size of the pore is more in case of sandy soil, but in case of clay soil, the average size of the pore will be less, because more number of micropore is present. Okay. So this is the concept. So I hope if you have given the ball density and particle density, so you can calculate the porosity by using the formula. So now the next thing is that void ratio. So porosity means it will include, porosity means pore space with respect to the total volume, whereas void ratio, it is the pore space with respect to the volume of soil. So that means porosity is for agricultural purpose, agricultural physics, soil physics, or irrigation purpose, whereas void ratio, it is for soil, you can say soil engineering or mechanics purpose. For engineering purpose, void ratio is important, but for agriculture purpose, porosity is important. So void ratio means volume of pore space divided by volume of soil. So if we will see what is the relation between the porosity and the void ratio, this is the relation. F is equal to E by 1 plus E. This is the relation between void ratio and porosity. Okay, porosity and void ratio. So if you want to find out this formula, how this formula will be, we will get. So as you know that void ratio means E. E will be volume of pore space divided by volume of soil. This is the thing. And as you know that volume of pore space means what? It is nothing but volume of total minus volume of soil, yes or no, divided by volume of soil. So if we will write like this, volume of total divided by volume of soil minus Vs by Vs, so it will be Vt by Vs minus 1. And as you know that for this porosity is equal to porosity means what? Volume of pore space divided by volume of soil, yes or no. So basically this will be volume of pore space. Okay, so this will be volume of pore space divided by volume of soil. So volume of total minus Vs, so Vt by Vs. Okay, so porosity means what? Porosity means Vf by Vt. This is the thing. Okay, so here you can write out. So let us like this, Vf by Vs. Okay, so now you can write Vf. Vs means V, you can see Vt minus Vf, you can write this. So just reverse it. 1 by E is equal to Vt minus Vf divided by Vf. So it will be 1 minus E is equal to Vt by Vf minus Vf by Vf. So this will be Vt minus Vf minus 1. So 1 by E is equal to Vt by Vf means what? Vt by Vf means 1 by F minus 1. That implies 1 minus E plus 1 is equal to 1 by F. That implies 1 plus E by E is equal to 1 by F. That implies F is equal to E by 1 plus E. Okay, so this is the formula. This formula will start from here. Okay, so this is the relation between the porosity and between the void ratio. Then next, coming to the range of porosity. If we will see here the range between the porosity. So here the range of the porosity, it will come between 0.3 to 0.6, or if you percentage, it is 30 to 60%, it will vary. So if I will say ball density is 2.65, that means it is 2.65 heavier than water, because normally water density is normally 10 to 1. So 2.65 normal mineral soil, you can say it is 2.65 heavier than the water. Okay, so next, coming to water content or mass wetness. Always remember, whenever we are going to calculate the water content, so in this case, what will be the formula? The formula will be mass wetness or on the basis of weight. This is weight by weight basis. Okay, this will be the weight by weight basis. So what we will do, so you will take the fresh soil sample, then keep it in hot air oven. Okay, then you are taking, that means inside the hot air oven you are evaporating the water. So now what we will get oven dry soil wet after evaporation of the water from the soil, because this soil sample contains both soil as well as the water. So after keeping it hot air oven, the water will be getting evaporated. So now only remaining is the soil, which is the soil oven dry soil. So if we'll see gravimetric water content, means weight basis. So as you know that weight means mass into gravity. Okay, so gravimetric water content means on the basis of weight. So mass of which soil? Mass of oven dry soil divided by, water content means mass of water. You can see mass of water divided by mass of oven dry soil. Okay, this is the gravimetric water content. But in this case, if we'll see the volumetric water content, then it will be theta, and it will be the volume of water divided by total volume. So here you can say volumetric water content, volume of water by total volume, on the basis of weight, mass of the water divided by the mass of the oven dry soil. Okay, and if we'll see what is the relation between, this is volume by volume basis. Okay, so what is the relation between the volumetric water content and the gravimetric water content? So this is the relation, theta is equal to W into BD. It is very simple, because as you see here, you can deduce also this formula, because as in this case, theta means what? Theta means volume of water by total volume. This is the thing. And as you know that density of water is equal to mass by volume is equal to 1. That means mass of water divided by volume of water is equal to 1. So mass of water is equal to volume of water. That means instead of volume of water, I can write mass of water divided by total volume. Yes or no? So in this case, how can I write in this case? Okay, so mass of water I can write in this like mass of water divided by volume total into mass of soil divided by mass of soil. So now it will be get mass of water by mass of soil into mass of soil divided by weight of soil divided by total volume. So this will be mass of weight of water or by divided by weight of soil. This is nothing but the gravimetric water content, and mass of soil divided by total volume, it is nothing but the bulk density. So this is the formula. Okay, so I hope you have understood also this formula, and you can remember very frequently asked question in entrance examination, what is the relation between all these things. Okay, so then rest two things is there. One is, you can see, one is degree of saturation. Degree of saturation means, you have the pore space. Suppose this is the solid portion, if I will compact this soil, and this will be the pore space. So degree of saturation means, out of this pore space, how much of percentage of water is present, and how much of percent you can by subtracting from the pore space, you can get the how much a percentage is filled with air. So degree of saturation means it is nothing but the out of the total pore space how much of water is present. So this is the thing. The theta saturation will be volume of water occupied divided by volume of pore space. So likewise you can see air filled porosity means what? Volume of air. A volume of air divided by total volume. So this is the thing. So as you know that the total pore space is equal to volume of air plus volume of water. Okay. So I hope you have understood all these concepts regarding the soil physics. In the next chapter we will also cover some of the soil physical properties. Okay. So thank you so much.